In this short presentation, I will go through my research profile and suitability for this coil team project. I began my research journey with a summer research internship at Monash University in 2008. After that, I worked in a rail wheel dynamic simulation during my final year project. Then I did my PhD project in hybrid metal fabrication using combination of shear deformation and pressure force. While doing the PhD project, I have used two processes called AFSCE, which stands for axisymmetric forward spiral composite extrusion, and high pressure torsion known as HPT. I performed case study of copper-clad aluminium fabrication using these two processes. Here I showed the schematic of AFSCE process, a blanking test which I utilized to test the bond strength of the composite material, and the high pressure torsion process in this slide. In terms of research skills, I have experience in designing, fabricating, modeling and optimizing process conditions and test conditions. I have investigated bond strength of metallic composite samples and characterized the interface using optical, scanning electron microscopy, EDX, focused ion beam dissection method and XRD. I have also used EBSD technique to investigate the parent material and fine grain formation during the process. I used numerical modeling to design required test rig and capture boundary condition during AFSCE process. In addition to this, I have developed skills to write quality publications and mastered my ability to produce quality illustrations. While doing my PhD and currently I'm supervising young researchers and final year undergraduate students, I also work in collaboration with other researchers from various organizations. Here I showed the interfaces of fabricated hybrid copper-clad aluminium samples. When considering my numerical work, I can give the following examples. I used Abacus finite element package to model blanking test and used cohesive modeling technique to inversely predict the shear stress distribution during the composite blanking test. I have also performed finite element modeling for the axisymmetric forward spiral composite extrusion process. At a later stage of my PhD project, I have collaborated in applying material point method known as MPM using a mesh-free technique to predict boundary condition for the AFSCE process. I have also involved with rail wheel dynamic model simulation using Abacus steady-state transport theorem and biomechanical modeling of a human stair climbing gait analysis. I have experienced in using FEMAP, ANSYS, SolidWorks and Fluent softwares in my simulations. This is an example of a blanking simulation for a required test condition of a composite sample shown in this slide. I am particularly interested in this coil team project because I believe my experiences are best fit to this research project. I have the experience in working with solid-state welding processes, numerical modeling, and interfacial characterization of bonded interfaces. This electromagnetic pulse forming and welding process is an advanced high-speed manufacturing technique. These have the advantages of producing modern engineering materials. Also, this can be utilized to fabricate architectural hybrid materials. This process can attract people due to energy, efficiency, and high-speed performance. I believe that working in this project can be a wonderful experience for me in my academic and research career. I certainly believe that my research skills, interpersonal skills, and communication skills are transferable to this project. I believe that my practice of regular publications and problem-solving skills can successfully deliver the project objectives. From my literatures, I found a coupled electromagnetic and plastic model have been used to solve various electromagnetic forming problems in the past. One example of using an ANSYS simulation was performed by Gion et al. And another example is using COMSOL simulation with the coupled electromagnetic and solid mechanics model by Gawad et al. Shown here.